What is classification? When do we use classification?
When Y is categorical.
Yes, when we are trying to predict,
Yeah.
okay, data which are categorical, right?
Yes, sir. Yes, sir.
So with classification, we will be able to predict. With regression, you won't be able to predict.
Yeah.
Okay. Okay. So classification. Okay. So okay, we create classifier. Classifier is a model, just like regressor. We have classifier, and these are some of the terms that you will see here. Okay. Classifier is the algorithm. Okay, which is trained. Okay, trained algorithm using which we will be predicting the Y value. Classification model. Okay, so model is the algorithm that we select. Feature is the X value based on which we are going to predict the Y value. We have binary classification and multi-class classification and multi-label classification. Okay, binary means, you know, just two output, yes or no. Okay, kind of A or B. When you have more than two classes, okay, it is called as multi-class. Okay.
Yes, sir.
So multi-class assigned to one and only one label or target. See, so you have three values to predict, but answer will be one of the three values only. You will not have two values.
Okay, like if you're calculating average, the average is low, medium, high.
High. Yes. Answer would be either low or medium or high.
Yeah. Yes, sir.
Yeah. So, and then the concept is same. Okay. So whatever we did in the pre-processing steps are exactly the same. Okay. You have to make it ready for data analysis. Yes. The post-processing part, okay, the evaluation part is different. Okay. Because here you don't have numbers. You can't find RMSE. You don't have numbers. You can't find R square. We have something else here. We'll see.
Okay.
So let's go.
One second, sir.
Yes.
What is the difference between multi-class and multi-label, sir?
Okay. So see, so multi-class, okay, with more than two classes, right?
Yeah.
So like yes or no, okay. And if you have label, then it becomes a multi-label. Okay, label in the sense the value. Okay, say A, B, or C. Which category will it belong to? A, B, or C?
Okay.
Okay. Okay, so it is like multi-class. Okay, so multi-class is same value. Okay, like low, medium, high. You take out average, low, medium, high. But if you want to assign based on low, it becomes windy. Let's say. Okay, so pressure, for example, pressure. So pressure, you want to predict whether it will be low, medium, or high pressure. And then say if pressure is low, it is more of a windy label.
Okay.
Pressure is medium, it is more of a cloudy, something like that. So when you assign a feature, it becomes a feature. Okay, but everything is multi-class. Okay, but feature may or may not be there.
Understood, sir. Thank you.
Yeah. Okay, so this is the data set we'll take. Okay, and the output is done in the confusion matrix. Okay, confusion matrix is the output. Now we will do all this. Okay, but let's see this. So training and test classification. Here also we have it, right? Training and test. What happens? Okay. The different algorithms. Okay. Okay. This is the what? Okay. Confusion matrix is the way we evaluate our classification model. Okay. So in confusion metric, okay, we compare how many accurately you got versus actually it is. Okay, so again, concept is for single class, and you can extend the same concept for multi-class. Okay, and I'll tell you later how to extrapolate to multi-class. So let's say, okay, let's say in training, okay, in training, you have whatever X is there, and let's say in Y you have true, true, false, true, false. Okay, this is the actual value in the training also. And training also it is spread. You can predict, so you can train dot fit and you can say predict X train only, right? So you are teaching the same concept of asking the questions. Okay, so that's how you get a training accuracy, right? How do you get training accuracy? You predict, right? You do dot fit, right? Classify dot fit or regressor dot fit, and then dot predict also you do with the same training. Okay, don't provide Y value, just provide X training. So this is, let's say, actual in training, and this is actual on prediction on training. So okay, this is true, this is false. Okay, this is true, this is true, and this is, say, false. Okay, so this is your actual. Then you count how many. Okay, so we create confusion matrix is a 2 by 2 matrix. Okay, confusion matrix is a 2 by 2 matrix. This is actual value. Okay, so let's say actual value false and actual value true. Okay, this is your predicted value, false and true. How many, okay, true, okay, so this is predicted, right? So predicted, this is P, predicted. So this is true, okay. So true and false. So this is true and this is false we want, right? We start with predicted, right? So we start from here. So actually it is false, but you predicted true. Okay. Actually it is false, you predicted true. This is one. Then actually true and predicted true. So actually true and predicted true. So this is your two, right? Now you're saying predicted false, actually it is false.
One.
One. Okay. Predicted false, actually it is true.
One.
Predicted false, actually it is true. One. Right?
Yes.
So this is called your confusion matrix. So you're classifying, okay. So now if you see, these are your accuracies, correct values. Okay. And these are your wrong values. Okay.
Yes.
So accuracy will be correct. That is 2 plus 1, 3 by 5. 3 by 5 is your accuracy, which is what, 60%? So your accuracy is 60%. We got 2 wrong here. Okay. Now, predicted no, and actual no. Okay. It is called true negative.
Okay.
So we use something called as two values. One is true and false, and then negative positive. Okay. Negative positive is based on your prediction. Okay. So now you tell me here, this is what we got right, correct? This is what we got right.
Yes.
So this will be true. True something. We'll talk about it.
Mm.
This is what we got right. This will be true something.
Positive.
Okay. This
Yeah.
is, yes. This is
False.
false. We got it wrong. So we call it as false.
False.
Errors are false.
Yes.
Okay. Whenever you hear false, whether false positive or false negative, different thing, but false means you got it wrong. You predicted wrong. False positive or false negative means, okay, means error. True positive or true negative means, okay, you got it right. Okay. Now, next is negative positive. Negative positive means negative is always based on what you predicted.
Mm.
So this is true. What did I predict here?
False.
False. So it is your negative TN.
Okay.
True negative. Here we're predicting true, isn't it? So
Yes.
positive. Okay. Now
Yes.
it depends upon now see whether a player will hit century or not. So in this case, yes is positive, we call it. It positive doesn't always means positive news. Okay. It means whatever you are thinking is right. Sometimes we think bad also, isn't it? So positive means what you're thinking is got correct. Now, when a patient goes to doctor prescribes some tests, right? Why will doctor prescribe test? Because doctor is suspecting some serious problem, right?
Yeah.
So if doctor is suspecting serious problem, that means if the patient gets the problem, let's say, someone goes and the person is detected positive for cancer. Doctor prescribed the test because doctor predicted cancer, isn't it? That's why doctor prescribed. Otherwise, doctor would not have prescribed. They would have given some tablet and sent home. When patient got, cancer, so that is a positive news. I mean, news not positive, but in statistics, that is a positive thing. Whatever you guessed is correct. So it's positive. Okay. So what is that you are trying to predict, and you predict it right, whether it's negative or positive doesn't matter. When you get it right, it's positive. So in this case, for a patient getting cancer is positive, and since doctor got it guessed it right, it is true positive. Okay. Now patient came and doctor did not suspect cancer. Doctor sent it home. Go home. You are okay, fine. There's nothing, no problem with you. And after a few days, patient died because of cancer. So there, doctor, okay, what did doctor predict? Negative.
Yeah.
And it was wrong. That is false negative. Okay, doctor did not predict cancer. Okay, and the patient got cancer. So that means doctor predicted negative, and it was false. So false, that's a false negative case.
But
Okay.
sir, you said that the doctor had predicted if it is negative, he would be right. Is what the test thought.
Are you sleeping, Dhvanit?
No.
First case, I said doctor prescribed test because doctor was predicting it'll have a cancer. Second case,
Right.
I am saying doctor sent home without giving test. When will doctor send you home? Because when doctor doesn't suspect any problem, isn't it?
Right.
You go, doctor say, okay, you look fine, take this tablet, go home. So in this case, doctor
Right.
is not predicting any problem, right? And the
Okay.
patient actually got serious case of cancer later. So that means doctor
Oh.
was wrong. Doctor did not predict, and the patient had it. Okay.
Right.
Now, when doctor doesn't predict and patient doesn't get cancer, it is negative. True negative. True negative means doctor got it right. Said no, you do not have any problem, and the patient did not have any problem. So it's true negative. But
But
patient,
why would that not be true positive?
Purita will explain to you.
Positive outcomes is considered as if the patient is having cancer, positive. Cancer, yes or no, in the sense positive means yes. If the patient is not having cancer, if you have options yes, no. When the patient is not having cancer, we'll go for opting no. That is negative outcome.
Yeah.
Okay. So we always
Okay.
look from the prediction perspective. What are you predicting? Okay. We
Okay.
always look from the prediction perspective. What is doctor is predicting? Doctor is predicting yes or no? Tell me. What did doctor predict? Yes or no?
Doctor predicted no.
So it is negative. No means negative.
Okay.
But
But it is
was doctor right or wrong?
wrong.
No, ask
Wrong.
Dhvani.
Okay.
Wrong.
Doctor is wrong, it is false positive. Doctor is right, then true negative, false negative.
Okay.
Okay.
Okay, sir.
Always based on prediction. Okay. What did you
Okay.
predict? No. So it is no, negative. But you got it right or wrong? I got it right. So
Wow.
true negative. No, your doctor got it wrong. So false negative.
Okay.
Okay. So false
Okay.
negative, true negative, false positive, and true positive.
Okay.
True means prediction and actual are same. Okay.
Okay. Yes.
False means it's wrong. Wrong what? Based on prediction. Okay.
Yes.
So we call it as, okay. So in this case, you have true negative, true positive.
False
Okay. This
negative,
is
false.
false prediction is here, right? So it is false positive.
Yeah.
Okay. P3, this is predicted T, right? And this is your false negative. Okay. So, okay. So this is your this. Okay. Now, there is something called as type 1 error and type 2 error. Okay. So your false positive, okay, false positive is called type 1 error. Also, we call it as type 1 error. And false negative is called type 2 error. Okay.
Yes.
Type 1 error means what? You suspect and you suspect that something is going to happen and you are ready for it and it did not happen. Type 2 is when you do not suspect and something bad happens. Typically, which is more bad?
Type 2.
Type 2 error is more bad, right?
Yes.
In first case, okay, you predict something bad will happen. You are ready, you have done everything ready, but did not happen. Good, no.
Yes, sir.
Okay, something bad did not happen. So generally, we talk in terms of bad only. Okay, because of the historical reason, that this been used by healthcare biology. Okay, it can be positive also. You suspect some great thing to happen, it did not happen.
That will
Okay,
be more.
that is also false positive. You
Okay.
wanted it to happen. Okay, India winning the match, you wanted it to happen but did not happen. False positive. Okay, that is
That
type.
was a horrible match.
Then false negative is like you don't. So see, something we are not prepared is considered bad, right? Even for good news you are not prepared. Okay, people who when you are not prepared is considered to be bad, isn't it? So generally type 2 error is considered as worse error than type 1.
Yeah.
Okay, now based on this we have many formula. Okay, I just showed you what is accuracy. Accuracy is TP plus TN, true, TP plus TN divided by TP plus TN plus FN plus FP, right? And we have whole list of formula here. Okay, okay, accuracy we told you, right? TP plus TN by total. Misclassification rate. Misclassification is Fn plus Fp, opposite of TP. Okay, 1 minus accuracy or Fp plus Fn by total.
Okay.
Okay, it is also called as error rate. Misclassification rate or error rate. Opposite of accuracy is error, isn't it? Then you have sensitivity. Okay, a sensitivity is also called as true positive rate. TP by actual yes. Okay, actually yes, but out of actually yes, how many you got it right? Okay, that's called sensitivity. False positive is FP by actual. Specificity, okay, is your TN by actual no. Precision is TP by predicted yes, and prevalence is actual yes by total. Now you'll ask me why so many metric is used. Okay, now I'll give you an example. Okay, let's say there's a multiple choice question or true false questions. Okay. So you have true, false, actual values. Okay. True, false, true, false, true, false, true, false, true, false, true, false. Okay. Let's say this is actual. Okay. One fellow, what they did, he marked all true, 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 true. Got 50%. Okay. This is one's first student. Second student, okay, did true.
Sir, quick question.
Yes.
How much did the, so for the first students, he said true, false, true, false, true,
No, no,
false,
no.
and then
This
he
is the
said true.
actual.
Oh, that's
This is the actual answer.
Okay.
This is the
Okay.
actual answer. Okay.
Okay.
True, false, true, false, true, false, true, false. And this fellow marked everything true, 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 true. And second
Okay.
fellow, okay, is actually solving. Okay. False. Then, did false here, true here, true here, and true here. Now you tell me, without looking marks, who is a better student, 1 or 2? True,
Well,
right?
just without looking. Yeah.
Yeah, because 2 is trying to solve, right? 2 is trying to solve. But here, true
But
might
it is
get only.
NZ, sir.
Huh?
NZ, not AAA. No negative marking, no, sir.
No. It's not about no negative marking. I'm saying
Yes,
you
I
want
got
people
it, sir.
see. So,
Yes,
no, no. So what I'm saying is, you want model, you want algorithm which thinks,
Yes.
not who just marks up and gives some random answer.
Yeah.
Okay. Now, because when you talk about this one, credit card fraud examples. Okay. Now, in credit card fraud, every hour, okay, thousands of transactions happen. Okay. But out of thousands, just 1 or 2 could be fraud transaction. Right.
Yeah.
So, you have false, 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 actual prediction, whether, actual value. Okay. So you have false, 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 and 1 true here. Now, if your model, okay, assumes all false, 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 even this also false, you will get 99.99% accurate. Correct? Only one wrong out of 1,000. But your model has not performed what you're supposed to perform. Your model is supposed to identify the fraud transaction.
Yeah.
Okay. So,
but it is considering all as fraud only.
Yeah, it's saying, okay, anyway, 1 is no, I'll ignore 1. Okay.
Yeah.
Right. You say, okay, I don't care, I'll get 99.99%, I'm happy. No. So you don't want such model. You want model which actually thinks, okay, even if it is okay to predict few extra wrong. Many times you get a call, right, that your card has been swiped. Is it you or somebody else? Okay. It is okay that you classify few correct transactions as fraud and have a check. Then on their 95% accuracy is better than 99% accuracy.
Yeah.
If you are able to capture this, if you are able to capture one transaction which is actually fraud, okay, along with that one, you are able to capture few other as wrong, it's fine. Okay, but I don't want 99.99% accuracy. I'm 95% accuracy is better. And if you catch that one error, one fraud transaction.
Yes, sir.
Right? So that's why we have so many metrics. We don't just go by accuracy, right? You might end up with this situation. Maybe this fellow has got only 40%, but this fellow is more hardworking. If you have to hire, you better hire this fellow because he's thinking hardworking than this lazy fellow, just marked everything TT and, maybe got 70% or 60%.
Yes, sir.
Okay. So that's
But
why.
Sir,
yes.
Even though this guy got, what do you call it, 40% or 30%, we would have to, if to hire, we would have to teach him more than the other guy, right? Who got a 50%.
It's the reverse thing. You don't have to teach him more. Okay. Hardworking people, you don't have to teach. They will know this. This fellow, lazy fellow, will try to skip, will not do your work, just like you done it. You know,
No.
when you don't come to class for 2 days, still you're not, you know, you're not going through. So I'm okay if you give me wrong answer by studying, then not studying at all.
Yeah.
Okay. If you study and give me wrong answer, that means you are trying. Okay. If not today, tomorrow. If not tomorrow, day after, you will get it right.
Yeah.
But if you're not studying, never ever you'll get it right. You agree?
Yes, sir.
Yes.
Okay. If I had asked what is linear regression, your answer would have been perfect. Okay. And I would have said very good. But then you said something without knowing what the question is. You got it right. You got it wrong this time. So it's always better to go for somebody who's hardworking, and in real life also. Okay. So in job, you will see that if somebody is performing poor, they're given 1 or 2, 3 chances. But if you find their attitude is wrong, okay, they
Yeah.
you know they are fired immediately. Correct?
Oh.
Yes,
Yeah.
attitude, and if you have behave any misbehavior and things like that, no chance, no questions asked, direct fire.
Yeah. In school, they also do that. They'll
Exactly.
expel you.
Exactly. They'll expel you. Performance, they'll give you chance, 1 chance, 2 chance, 3 chance. Finally,
Yes.
then they'll expel you.
Yeah.
Right? So that's what. So we want algorithms which thinks. Okay. So who's thinking, who's studying, who is hardworking, eventually will get it right one day.
Right.
Okay. But who's not thinking, who's not willing to put hard work, will never ever get it right. Which is true with algorithm also. That's why we want algorithm to think. And see, this is not, as I told you, right? When you provide right data, more data, the algorithm will get it eventually right. Okay. So that's where we have to look at what is sensitivity, what is true positive. Now, in this case, actually yes, and to actually yes is no, in this case, this fellow has put all truths, right? So what will be the sensitivity value or true positive rate for the for this second guy?
100%.
Right? So true positive means how many positive he got right. So there are 5 true positive, he got all 5. And actually, yes, he is also 5.
Yeah.
100%. So you see, the accuracy is 50% and true positive is 100%. Clearly, there is a problem.
Yeah.
It should be in same range, 70% around. Okay, or
Yes.
50% around, or 70% around. If you get 100% sensitivity or 100% specificity and 50% accuracy, gone. You know that fellow. So that's why we should not just look at one metric. We should look at multiple metric. If I made head of MSET right, I would have also calculate other metric, and total score will be based on multiple values, not just one value.
The guy who woke up with MSET, he ended up in maybe AAAA, sir.
Yeah, it happened.
That's actually good, sir. Like negative marking, many, like even I also have done whatever answers I have not known. I just gone for randomly marking.
See, that is the thing. That is the thing. You are not given. You are there should be, and negative marking is 1/4.
Yeah.
Right.
Yeah.
So
Yes.
even if you get it wrong, you are losing only 1/4. But if you get
Yes.
right, so if you mark all four as, let's say, B, okay, you are more chances of getting. So that is that is the way the system is, right?
Yes, sir. Yes.
That's the way system is. So we have to play. Now, if you calculate all these things, sensitivity, specificity, precision, prevalence, all this, if you calculate and then if you give score, then nobody will do like that.
Yeah.
So it is the system is like that. So what can we do? Right?
Yes, sir.
Okay. So this is what we call as confusion metric, and this is equivalent of RMSE and R square of regression. Then we also call it as PPV, positive predictive value. Okay, this is a formula. Number of true positives by number of true positive plus number of false positive. Okay, but you don't have to remember all these. Okay, the metric, scalar metric will have all these values. Okay, but this is just for your knowledge that this is what exists.